Good morning, students. Welcome back to physics class. I hope all of you learned the previous topics very well. Today we are going to discuss about solenoids and toroids. So let us start our class. First we have to study about solenoid. So let us study what is a solenoid. A solenoid is an insulator copper coil is wound around some cylindrical cardboard or plastic tube such that the length of the coil is greater than its diameter, then it behaves like a magnet when an electric current flows through it. It is called a solenoid. So what is solenoid? A solenoid means the insulator copper wire wound closely in the form of a helix. Okay, then look at the figure of a solenoid. When an electric current is made to flow through it, then each turn of the coil behaves like a magnet, isn't it? In figure A, current is flowing into the coil in clockwise direction. So the coil left hand side of the each turn of the coil acts at south pole. Okay? Whereas right hand side of each turn of the coil acts as north pole. Okay? So, in figure B, the current is flowing into the coil in anti-clockwise direction. Okay. So, in the second figure, the current is flowing in the anti-clockwise direction. So, the left hand side of each turn of the coil acts as north pole, whereas the right hand side of each turn of the coil acts as south pole. Okay. So, the situation became similar to a number of small bar magnets placed end to end with their opposite poles facing each other. Okay, so solenoid's magnetic field is same as that of a bar magnet. So, it is clear that if a number of turns to a solenoid increases, then the magnetic effect also increases. Then the next one is expression for the magnetic field inside a long straight solenoid. So what is a solenoid? A solenoid is a long coil containing large number of closed ends of insulator copper wire. So here we have to consider the sectional view of a long solenoid. Sectional view of a long solenoid. And also you know that the magnetic field inside a closely wound long solenoid is uniform everywhere. That means inside the solenoid the magnetic field is same. Parallel lines. Okay. So inside the solenoid the magnetic fields are same. That means suppose this one is a solenoid. So in that case it behaves like a bar magnet. So inside the solenoid the magnetic fields are same, parallel and uniform. Okay. But outside the point, suppose we have to consider a point Q. So here this is a point Q. So in that case the magnetic field is what? 0. Okay, so magnetic field inside the solenoid magnetic field is same, but outside the same means uniform, but outside the solenoid the magnetic field is 0. Understood? And also you look the picture. So this is a sectional view of a solenoid. In that case, at various turns of the solenoid, current comes out of the. So this is the point. Here the current comes out. Current comes out of the plane of paper at points marked as dot. So this is the point where the current comes out. Okay. Then the current entering into the paper because it is a coil. So this picture is a sectional view of a picture. Okay. So the dot means the current comes out of the paper and cross means what? The current entering into the paper. Understood? So what is dot? Dot means current comes out of the plane of the paper. Then what is what is the meaning of cross? Cross means the current enters the plane of the paper is marked as cross. Okay. Then we have to consider a ambient loop. Ambient loop. A rectangular ambient loop A, B, C, D. Okay, a rectangular ambient loop ABCD, then its length is H. Okay, then and also you know that we have to consider point P inside the solenoid. So the magnetic field is uniform here, but at the point Q, the magnetic field is 0. Okay. Then to determine the magnetic field B at any point inside the solenoid, consider a rectangular loop ABCD. Okay. Then you have to apply the Ampere circuit law. Which law? Ampere circuit law. So you know that what is the Ampere circuit law? That means integral of, close integral of what? B dot, close integral of B dot dl is equal to what? B dot dl is equal to mu 0 into total current. Total current through the loop. Which loop? ABCD. Total current through the loop ABCD. So we have to apply the Ampere circuit law. So integral of B dot dl is equal to what? Mu 0 into total current through the loop ABCD. Okay. So integral of B dot dl, which is equal to integral of, we have to consider this loop. So this becomes A to B, integral A to B, B dot dl plus integral of B to C, this one B to C, B dot dl plus integral of which one? C to D, this side C to D, B dot dl plus integral one more side D is A, integral D to A, B dot dl. That then you have to see this picture again. So here integral of B to C, integral of B to C and integral of D to A. That means here integral of B to C and integral of D to A. So the magnetic fields are perpendicular to this one. That is angle theta is equal to what? 90 degree. So what happened? You know that integral of B dot dl is what? B dot dl is equal to integral of B dl cos theta. So here theta is what? 90 degrees. So what happened? This becomes 0. Okay. So integral of B dot dA, B to C, B dot dl is equal to 0 and also D to A, B dot dl is equal to what? 0. And also you see integral of C to D. C to D is outside the solenoid. So it's again 0 because magnetic field cannot exist here. So which is equal to what? 0. Okay. So this can be rewrite as, so this can be written as which is equal to what? Integral of A to B, B dot dl, which is equal to what? Mu 0 into total current. Total current. Okay. Then you know that H. What is H? H is equal to what? Length of the, H is equal to what? H is equal to length of the side AB. Side AB of the rectangular loop ABCD. Okay. So this one is the length. Okay. Then let number of turns per unit length of the solenoid is N. So what is N? N is the number of turns. So what is N? N is the number of turns per unit length of the solenoid. So this one is a unit length of the solenoid. What is N? N is the number of turns per unit length of the solenoid. Okay. Then number of turns in length H. Number of turns in length H of the solenoid becomes what? NH. Then total number of length of that rectangular loop, that means AB is equal to what? NH. Okay. Then what is total current? So you have to multiply it with the I. This one is the total current, NHI. Okay. So total current is equal to what? Total current is equal to NH into I. Okay. Then again write the Ampere circuit law, that is integral of A to B, B dot dl. B dot dl is equal to what? Mu 0 into total current, that means NHI. Okay. Then this side is also B into what? Integral of dl is what? Integral of dl means length of that loop, that is H. BH is equal to what? Mu 0 NHI. Okay, HH cancel, then magnetic field B is equal to what? Mu 0 N into I. B is equal to mu 0 N into I. So the magnetic field inside a long straight solenoid B is equal to what? Mu 0 N into I. Okay. Then one more equation. The magnetic field at the end of the solenoid is just one half of that of its middle. That is, magnetic field at the end of the solenoid B and is equal to what? Half of mu 0 Ni.